Okay, to find the resultant force of this 9 Newton and this 12 Newton forces, you can use the parallelogram method, since now the tail of both forces, they are together at O. So what we do is that we draw a parallelogram, and the resultant force will be from O to Q. So this is a right angle triangle. So the magnitude of this resultant force is actually the hypotenuse. So what we can do is use the Pythagoras theorem. Resultant force is equal to square root of 12 square plus 9 square. So we get the answer as 15 Newton OQ. Answer A. We have a speed time graph in question 2. So we need to know that the gradient of a speed time graph gives us the acceleration. So starting from point A, the gradient increases because it's getting steeper and steeper. So the acceleration increases. And starting from B is a straight line, so the speed increases at a constant rate. We have constant acceleration. And from C onwards, we see that the gradient is decreasing, so we have a decreasing acceleration. And at D is a horizontal line, so we have a constant speed with zero acceleration. Okay, so since we are looking at the point in the balloon's rise where the acceleration starts to decrease, so C is our answer. To find the average speed, we have to use the formula total distance divided by total time. So the total distance can be found by taking the area under graph throughout the 3 seconds. So this will be half times 3 times 12 divided by the total time taken. It will be 3 seconds. We have 6 meter per second. Answer B. Okay, there are two forces acting on this car. There's a forward force F and a resistance force R. So when force F is equal to force R, what we are expecting to get, it will be a zero resultant force. That means there will be no acceleration, and we should expect to see constant speed, since the car is already moving forward. Okay, so now we look at the options. The car is moving with non-uniform acceleration. This is wrong because there shouldn't be any acceleration at all. Option B, the car is moving with uniform acceleration. This is wrong as well. The car is moving with uniform velocity. Okay, constant speed, uniform velocity, they are the same thing. So C is the answer, and the car is stopping. Okay, this is not correct because the car is already moving forward. So even when there's no resultant force, the car is supposed to move forward at the same speed. Okay, the inertia of a body is its resistance to change its motion. Okay, so we need to know that mass is the thing that will affect the inertia. The larger the mass, the larger the inertia. Okay, so mass is a measure of the body's inertia.